Hello, today we'll be comparing a high-end multimeter with a budget model to see what differences they offer. This is the first meter. This is the Hioki DT4282, a professional-grade digital multimeter. It sells for around $300 to $400. And here's the other one. It's a digital multimeter I bought on Amazon. It's made by a brand called Astro AI. I'd never heard of it before, but it has excellent reviews on Amazon. I originally bought this Hioki multimeter with the intention of taking it apart. However, I ended up using it for a while before disassembling it, and its ease of use and wide range of features quickly made it one of my favorite meters. So today, I'm comparing this budget meter with a high-end one to see just how much of a difference there really is. You might be wondering whether a low-cost meter is all you need, so let's find out. This video is a bit long. In the first half, we'll look at the design, specifications, and usability of the two meters. In the second half, we'll measure voltage and current to evaluate their actual performance. But first, a quick shout out to today's sponsor. If you're looking for low-cost PCBs, I highly recommend JLC PCB. Recently, they've been putting a lot of focus on multi-layer PCB production, and they'd really like you guys to try their 6-layer boards. 5 100 by 100 6-layer boards are just $36.8. They also now offer Pad-on Via, an essential feature for high-density designs, at no additional cost. They're currently offering coupons for 6-layer boards, so now's a great time to try JLC PCB. Here are the two meters we'll be comparing today. One is a digital multimeter made by Hioki Electric. The other is a Chinese-made digital multimeter that I bought on Amazon. The price difference is roughly tenfold. We'll examine performance differences, such as how quickly measurements are displayed and how many digits each meter can show. You can find links to all the equipment used in this video in the description. You can get the Hioki meter through the hometown tax program of Ueda City, Nagano Prefecture. You might want to consider getting it that way. Now, let's compare the two in more detail. First, we'll examine the Hioki meter, DT4282 digital multimeter. According to Hioki's website, it is a top-of-the-line digital multimeter. One notable feature of Hioki products is that they are made in Japan. This meter typically sells for around $300 to $400. For a handheld digital multimeter, that's certainly on the expensive side. You could even call it a luxury item. If you're willing to spend even more than this, benchtop multimeters start to enter the picture. In Hioki's catalog, the DT4282 is positioned as a high-end model for laboratory and research applications. The specifications are summarized in this catalog. There is also a closely related model called the DT4281. That model is designed primarily for electricians. Next, we have the DM6000AR digital multimeter. I found this one while browsing Amazon. It's a feature-rich digital multimeter at an affordable price. For this comparison, I picked this model because it's similar to the Hioki meter both visually and functionally. The price is around $25. I wouldn't exactly call it dirt cheap, but for the features you get, it's definitely a great value. For those who are planning to buy their first multimeter, my personal recommendation is to start with a reasonably priced model in the $20 range and learn the basics. Then, if you find that you need more features or better performance, you can upgrade to a higher-end meter later. Next, let's take a look at the design and build quality. First, let's compare their weight. The budget meter weighs 339 grams. The Hioki meter, on the other hand, weighs 644 grams. When you actually hold it, the Hioki meter has a solid weight. If you're going to hold the meter while using it, the lighter one has its advantages. Next, let's take a look at the magnet on the back. First, here's the budget meter. You can see that it has a magnet on the back. It's surprisingly strong. Most electrical panels are made of materials that magnets will stick to. That's why a magnetic strap like this is very convenient. As for the Hioki meter, it does not come with a magnet. If you want one, you'll need to purchase a magnetic strap separately. Since a magnet is so convenient, I think it should be a standard feature on all meters. So this meter that we're using in this video uses a magnetic strap, but some meters have a magnet built into the back of the meter itself. Next, let's take a look at the back of the meters. The Hioki meter has grooves on the back. You can insert the test leads into them like this. They serve as storage slots. The budget meter doesn't have this feature. I think those storage grooves could be useful in some situations. Next, let's look at the stand on the back. The Hioki meter has a small recess here, making it easy to flip the stand open with your finger. I think it's a very convenient design. The budget meter, on the other hand, isn't as good in this regard. This opening is so small that it's difficult to get your finger in. That makes the stand hard to open. You have to hook your finger into this recess to flip the stand open. Once it's open, the meter stands normally. There's no problem with that. Right now, I'm wearing relatively thin gloves. But let's see what happens with thicker gloves. I've switched to these insulated gloves. Gloves make fine manipulation much more difficult. But thanks to the recess here, Hioki meter still opens easily. The budget meter, on the other hand, is practically impossible to open. It's really difficult to open. Next, let's look at the batteries. Both meters have screw-secured battery covers. Removing the screws allows you to open the battery compartment. The Hioki meter uses 4 AA batteries, whereas the budget meter uses a single 9-volt battery. If you take a look at this area, you can see that the more expensive model uses a higher quality molding. As you'd expect from a more expensive meter, the battery compartment is very well designed. As for the budget meter, it seems like the battery connector could tear off after a few battery changes. Another factor to consider is battery availability. Personally, I find 4 AA batteries more convenient than a 9-volt battery. Let's take a look at how the battery cover is fastened. The Hioki meter uses metal-threaded inserts. The budget meter, on the other hand, uses self-tapping screws. The batteries for meters don't need to be replaced very often. Even so, the Hioki meter uses metal inserts to ensure long-term durability when the battery cover is opened and closed repeatedly. As you'd expect given the price, details like these have been carefully thought out. Hioki recommends using either alkaline or manganese batteries. However, I was curious about using rechargeable batteries, so I decided to test them. As you can see, the meter powers on when using 1.2 volt NiMH rechargeable batteries. We were able to confirm that the meter powers on, but I'm not sure whether the measurements will still be accurate when using NiMH rechargeable batteries. Later, I'll check whether the difference in battery voltage has any effect on the measurement results. Next, let's check the included test leads. Both can be used without any issues. As for the cables, the Hioki leads feel a bit more flexible. The budget meter's leads feel a bit stiffer. Now let's take a look at the tips of the test leads. Both have the same shape. The leads come with detachable tip covers made of plastic. As expected from the more expensive Hioki meter, the cover fits much more securely than the one on the budget meter. Listen to this. You can hear it click into place. The tips of the Hioki leads are gold-colored. I can't tell whether they're actually gold-plated or just have a gold-colored finish, but they certainly look gold. They seem to be resistant to corrosion. On closer inspection, there are also differences in the contact points between the test leads and the meter. Hioki meter's lead connectors use a multi-contact design. This design helps reduce contact resistance. On the other hand, the budget meter's plugs are split into 4 segments. So we've taken a look at the physical differences between the high-end meter and the budget meter. Next, let's move on to their features and performance. Let's check the backlight. The display can be read without the backlight. It looks darker on camera, but it's easy to see in person. The Hioki meter has a dedicated backlight button. On the budget meter, the backlight is turned on by pressing this button and holding it down. As for the backlight on the Hioki meter, I find it a little dim. Here's what it looks like. Personally, I think it would be more usable if it were a little brighter. The budget meter has a blue backlight. This also has its own visibility issues. Personally, I like the backlight on this meter the most. It's bright and easy to read. One of the most interesting differences in the appearance of these meters is the input jacks. The budget meter uses a standard design. The Hioki meter has an interesting mechanism. Right now, these 2 jacks are open for measurements other than current. However, when I switch to current measurement, the accessible jacks change like this. It's in the milliamp range. When I switch the dial to the amp range, the open jacks change like this. Once the test leads are inserted, the dial is locked. To change functions, you need to remove the leads and insert them into the appropriate jacks again. The same applies when switching from the microamp or milliamp range to the amp range. Once the lead is moved to the other jack, the dial can no longer be turned in this direction. This is a foolproof feature. It's also known as pokayoke in Japanese. To prevent measurements from being taken in the wrong range, the accessible jacks change automatically. Next, let's take a look at the meter counts. I'll explain how meter counts work while measuring voltage from this DC power supply. Meter counts refer to the number of digits and the range of values the display can show. This budget meter has a 6,000 count display. As the product name suggests, it is a 6,000 count meter. The Hioki meter is a 60,000 count model. Generally speaking, higher counts mean more digits and a wider display range. Let's take a look at the actual differences. The meter on the right has 6,000 counts, while the meter on the left has 60,000 counts. The number of digits displayed is different. A 60,000 count meter can display up to 5 digits and typically shows 4 digits. A 6,000 count meter can display up to 4 digits and typically shows 3 digits. Let's gradually increase the voltage. Let's focus on the displays when the voltage turns 600 millivolts. Both meters are currently showing 590 millivolts. I'm going to increase the voltage of this power supply to 600 millivolts. Take a close look at what happens next. The number of digits displayed has changed. The number of digits on this budget meter hasn't changed. However, if I increase the voltage a little more, it will change. It switched to 3 digits. As we've just seen, both the 6,000 count and 60,000 count meters lose 1 digit when the leading digit reaches 6. Like this. So that's meter counts. We've looked at 6,000 count and 60,000 count meters. For example, with a 9,000 count meter, the number of displayed digits decreases by 1 when the leading digit reaches 9. We just tried 600 millivolts, so now let's see what happens at 6 volts. The voltage is now 599 volts. The 60,000 count meter is showing 5 digits, while the 6,000 count meter is showing 4. If I increase the voltage further, the 60,000 count meter loses 1 digit. The 6,000 count meter hasn't lost a digit yet, but that's due to its internal processing. If I increase the voltage a little more, it loses a digit as well. So far, we've been looking at handheld digital multimeters, but there are also benchtop models like this one. This meter is rated at 6.5 digits. That's a different concept from the counts I explained earlier. It can be a bit confusing as well. Meters specified as 6.5-digit meters usually display 6 digits. If the voltage is increased, they can display up to 7 digits. Let's increase the voltage further. When it reached 1.2 volts, the display lost 1 digit. This digital multimeter is called the DM6500, and that's how it displays voltage. As mentioned earlier, I'll now check whether using NiMH rechargeable batteries has any effect on the measurement results. This time, instead of using batteries, I'll change the voltage supplied to the meter. Right now, I'm measuring a DC voltage of 1 volt. Both meters are reading 1 volt. The Hioki meter is being supplied with 6 volts. This simulates the voltage of 4 AA batteries. Next, I'll gradually reduce the supply voltage. If the Hioki meter's readings remain unchanged, that would indicate that rechargeable batteries can be used without any issues. I'll gradually reduce the supply voltage to the meter. It's now at 5 volts. The battery indicator has dropped by 1 bar. Even at 5 volts, the meter still works normally. The reading remains unchanged. I'll lower the voltage a bit further. We're now at 4.8 volts. That's the voltage provided by 4 NiMH batteries, which are rated at 1.2 volts each. The reading hasn't changed, but the battery indicator has dropped further. I'm lowering the voltage further to 4 volts. The meter still seems to be working normally, but the battery indicator is now blinking. That doesn't look very reassuring, although the meter is still usable. I've lowered the voltage further to 3.8 volts. It's still barely usable. I'll lower it further to 3.7 volts. Actually, let's go even lower. 3.6 volts. The low battery warning has appeared. At this point, it's not usable anymore. If you look at the Hioki meter's instruction manual, it recommends using alkaline or manganese batteries. Battery replacement isn't something you'll need to do very often, so I think regular AA batteries are the way to go. We'll begin the measurements shortly, but first let's briefly go over what each meter can measure. The measurement functions are almost identical on both meters. The Hioki meter can measure AC and DC voltage, diode forward voltage, continuity, resistance, temperature, capacitance, conductance, and current. Both voltage and current can be measured in AC and DC modes. Most of the measurement functions are the same on this budget meter. However, it also includes a function for measuring transistor HFE, or DC current gain. There's also an unfamiliar symbol here. This is for current measurement using a clamp. First, we'll measure DC voltage. We'll compare the accuracy of the readings displayed here and take a look at how quickly the measured values are displayed. To keep the measurement conditions consistent, I'll use auto range for all measurements. This time, I'll also show the reading from this benchtop digital multimeter. I'll use the reading from this benchtop digital multimeter as a reference. I'm currently measuring a DC voltage of about 100 millivolts. Actually, it's about 100.05 millivolts. The Hioki meter reads about 100.05 millivolts, matching the reference. The budget meter reads around 99.9 to 100.0 millivolts. Let's see how long it takes for the reading to appear. They're about the same at 100 millivolts. Next, 12 volts. So that's how they compare. What do you think? From what I can see, the Hioki meter seems to have a faster response time. As for the voltage measurements, the Hioki meter matches the reference meter, while the budget meter differs by about 10 millivolts. And finally, let's test DC 600 volts. However, the meters we're using lose a digit at 600 volts, so we'll test at around 595 volts and 630 volts instead. Alright, here we go. First 595 volts. That's the result. As expected, the Hioki meter responded immediately. Let's do it one more time. I'll press the button now. The high-end meter displays the measured voltage first, while the budget meter takes a little longer to catch up. As for the displayed voltage values, they are all different. However, the benchtop meter and the Hioki meter show very similar readings. The budget meter, on the other hand, reads about 1 volt lower than the other meters. Let's do it again. I'll press the button. As expected, this benchtop meter responds the fastest. Up to this point, both meters have been set to auto range, but now I'll switch to manual range. Here's what happens. Hi. In manual range, both meters display the voltage faster. If you already know the voltage range you'll be measuring, I recommend using manual range. However, switching ranges manually can be inconvenient, so I generally recommend auto range. Next, I'd like to take a closer look at the points where the 60,000 count and 6,000 count meters lose a digit. I'll apply a voltage of 630 volts. Here we go. Here's what happened. They're both in auto range, and the response times are quite different. I'll do it again. Still quite different. When it comes to response time, the price difference seems to make a significant difference. Next, let's measure the AC voltage. This setup isn't exactly safe, but let's not worry about that for now. Here we go. This is what happened. This budget meter had the fastest response. The Hioki meter had a slower response. Regarding the measurement values, since we're using commercial power this time, the amplitude tends to fluctuate quite a bit. So please treat these as reference values. The Hioki meter simultaneously measures the RMS voltage and the frequency of the signal. This is quite an interesting feature. By the way, if you press the shift button here, you can switch modes. In this mode, you can separately display the DC and AC components of the voltage. If you use a signal generator to output a 5-volt RMS signal, these are the readings. I hope you find this helpful. Based on the results, the budget meter seems to perform better here. Let's see how high we can increase the AC frequency. It's at 1 kHz with a 5-volt signal. Let's increase the frequency further. As we increase it to 2 kHz and 3 kHz, the budget meter's reading starts to drop. The Hioki meter is still measuring accurately. We will further increase the frequency. It has reached 10 kHz, but the Hioki meter still reads 5 volts accurately. The voltage reading on the budget meter has dropped significantly. Looking at the datasheet for the budget meter, the frequency range is 40 Hz to 400 Hz. But it seems that the Hioki meter can go even higher. I will further increase the frequency. The Hioki meter can measure frequencies up to 100 kHz. However, this is the limit for guaranteed accuracy, so it's still possible to measure frequencies above 100 kHz. Just keep in mind that accuracy is not guaranteed. As you can see, the amplitude keeps decreasing. It seems this meter can go up to about 500 kHz. Above that, it no longer displays a reading. Actually, the budget meter has a mode for measuring frequency only. In this mode, it can measure frequencies as high as 500 kHz. The datasheet for the budget meter states a measurement range of 0 to 60 MHz. However, in practice, the upper limit is 25 MHz. If you try to measure frequencies beyond that, it starts displaying incorrect values. Next, let's measure DC. I'll start with a 10 amp range. On the Hioki meter, if you want to switch the dial to amps, you need to temporarily disconnect the test leads. Just like this. Let's start by measuring 5 amps. The reference meter reads 5.003 amps. The Hioki meter reads 5.004 amps. And the budget meter reads 5.036 amps. The Hioki meter is off by 0.03%, while the budget meter is off by 0.7%. Well, I guess this is about what I expected. Next, I'll switch the range and test at 100 milliamps. The Hioki meter is very close to the reference meter. The budget meter reads about 0.1 milliamps high. That's practically negligible. I'm currently measuring AC current. I'm measuring a small current of 15 milliamps. Here are the results. The readings are all very close. As I increased the frequency, the budget meter's reading started to decrease and eventually could no longer measure the current. The Hioki meter can measure the current without any issues. As expected, the budget meter has a frequency limit for current measurements, just like it does for voltage measurements. By the way, after finishing the current measurement, if you try to switch back to voltage measurement, the dial on the Hioki meter won't turn. This is due to the safety mechanism I mentioned earlier. You have to disconnect this test lead before measuring voltage. This significantly reduces the chances of blowing the fuse inside the meter or damaging the meter itself. Next, let's measure resistance. Since these meters measure resistance using 2 test leads, they're not very good at measuring low resistance values. If I short these test leads like this, the Hioki meter reads 0.037 ohms, which is fairly high. The same goes for the budget meter. It reads 0.2 ohms. With a benchtop digital multimeter, you can perform 4-wire resistance measurements. This is a 1 kilo ohm resistor with a 0.1% tolerance. It reads 1.00009 kilo ohms. I will measure the same resistor with these meters. However, these meters only use 2 test leads. This is Hioki's reading. It's 1.0001 kilo ohms. Let's also measure it with the budget meter. The result is 1.004 kilo ohms. The resistance value has slightly increased. I think this is because of lead resistance. Additionally, there is an issue with the accuracy of resistance measurements, which also has an impact. By the way, both meters have a function that cancels out the resistance of the test leads. Next, let's measure capacitance. I'm measuring a small capacitance of 220 picofarads, and the Hioki meter reads 243 picofarads. The budget meter can also measure the capacitance without any issues, reading 220 picofarads. Let's also measure a larger capacitance. This capacitor is 3.3 microfarads. It shows 3.48 microfarads. The same goes for the budget meter, which shows 3.46 microfarads. When measuring with a meter, larger capacitance takes more time to measure. This capacitor is 180 microfarads, and it takes about 3 to 4 seconds. The budget meter also takes about the same amount of time to measure. This electrolytic capacitor is several thousand microfarads, so it takes even more time to measure. I've connected the capacitor. It quickly settled on the correct range, but it's taking quite a bit of time to measure the capacitance. It took about 10 seconds. The same goes for the budget meter. It's taking quite a long time.
1、2、3、4、5、6。はい。
It took about this long. Lastly, I'd like to introduce the function on this budget tester that measures transistor HFE. I'll insert this transistor. The HFE is 323. The transistor is a 2SCU1815GR grade. Before concluding, I'll disassemble the meters and take a look inside. Can you tell which one is the expensive one and which one is the budget one? I think it's obvious at a glance. The Hioki meter is on the left and the budget meter is on the right. The Hioki meter uses an incredible number of semiconductors. Most of them are analog semiconductors. There is a microcontroller here. The Hioki meter uses a lot of components, which means it takes time to design the product. That is reflected in the price. Let's take a look at the budget meter. There is either a semiconductor or a microcontroller here, and apart from that, there are only a few analog components. This meter is made with a very small number of parts. Therefore, it can be made for less than 1/10 the price of the Hioki meter. Hioki's products are more advanced in terms of functionality, but I think this budget meter is good enough for most use cases. If I were to praise the budget meter, I'd say it has very few components, a simple design, and a low manufacturing cost. If I were to criticize it, it feels a bit like a toy. However, it has all the necessary functions. That's my impression. This Hioki meter allows you to detach the board. On the other side of the board, you can see the safety mechanism. If I disassemble the safety mechanism, it might not go back together, which could lead to a disastrous situation. So I'll stop the disassembly here. So today we looked at the differences between a budget meter and a high-end meter. We observed differences in response speed during measurements, as well as differences in measurement accuracy. Indeed, looking at the finer details, the high-end meter is clearly more refined, which is expected. That said, I wouldn't say the budget meter is necessarily bad. You can use it without any problems. In other words, it offers excellent value for money. As I mentioned earlier in this video, I think this budget meter is sufficient for basic electronics work. If you're thinking about buying a meter, it might be a good idea to start with a model like this for around $20 and learn how to use it. Learn how to use it, and if you need something more advanced later, you can consider high-end products like this one, as well as benchtop digital multimeters. If you're unsure which one to buy in the future, I hope this video will serve as a useful reference and help you decide which meter suits you better. The links to the products used in this video are listed in the description. If you're interested, please consider checking them out. By the way, you can get the Hioki meter through Japan's hometown tax program. If you're an electrical contractor or a freelance developer, I'd recommend buying it that way. Thank you for watching. See you next time.